Hello everyone. We are going to continue with section 1.3 on physical and chemical properties. These are the learning objectives for this section. Identify properties of and changes in matter as physical or chemical, and identify properties of matter as extensive or intensive. So let's get started. Here we're showing an example of a reaction occurring. We're showing the decomposition of water. It turns out if you put electricity through water, you can turn it into hydrogen and oxygen. And we're showing that here. And we're showing it again, so kind of a rehash of some things we talked about in the first two sections. We're showing it in three ways. We're showing the macroscopic. This is what it would look like if you were to do this in the lab. You'd have water and you'd have these bubbles in test tubes and gases forming, one of them with about twice the volume as the other. So that's macroscopically what you would see. If you were to zoom way in to the molecular level, you would see down here in the liquid, you would see these molecules that are showing, an oxygen and two hydrogens. Again, you don't have to know how to draw that right now, but that's what that would look like, would be these molecules. And then if you looked in each of these test tubes, you would see these molecules of hydrogen and oxygen, as we're showing there, where you have two atoms of the same element combined. And then symbolically, we're showing down here, we have, H2O for water, H2 for hydrogen, O2 for oxygen. Again, we don't have this alphabet soup of letters floating around in the water or the air. That's how we're showing what's going on. And when we see these symbols, we want it to know that that means what we're looking at here and here. So just a little bit of a reminder of some of that stuff from the previous section. Also, this is how we might know that we are having what we would call a chemical change. When we have a chemical change, we have some sort of rearrangement of the atoms that make something up. So that's kind of our, if we know that, if we happen to know that, we would know that we have a chemical change. But we don't always have this information, right? We don't always necessarily know everything. So we want to know maybe how to figure that out if we don't know everything, whether it's a chemical change or a physical change. Okay, so here we're looking at two changes that when you think of them, you might think of them as being similar to the situation where we were, putting electricity into water and we're making these two different gases. So we see melting wax, so we have a fire going on and then the wax is melting. That seems like a pretty big change. And over here we have steam, basically water boiling and forming steam in this pot. But these changes, it turns out, are mostly not chemical changes. I say mostly. There is a flame here, so there is some amount of a chemical change going on. But what we can do is if we take this wax that has melted, we can reshape it and come back to the same type of candle that we started with. So that change from a solid to a liquid doesn't actually count as a chemical change. We would actually call that a physical change because we're changing the physical properties, but we're not changing the chemical properties. We still have wax. The same thing with the boiling water. It is still water. We're not making hydrogen and oxygen. We're just changing the physical state of the water, and it's now a vapor instead of a liquid. And one way we can know that is if you have a cooking pot like we're showing here, You can see the water droplets are forming on the lid, so the water vapor is turning back into um, to liquid water. And this is actually how I go about thinking about, is a change a physical change or is it a chemical change? And what I think about is, can you get back to what you started with? And if so, how easy is it to do that? You can always get back in some way by going through a complicated series of chemical changes. But is it easy to do that? And if it is easy, then you're probably talking about a physical change. So if you can change the temperature and you get it back, then you're looking at a physical change. Um, if it takes something a bit more complicated, then it's probably a chemical change. Here are some examples of um, chemical changes. So rusting metal, okay? We can't really easily get that back. Maybe you can scrub it off, but then it's gone, right? So you're not really turning it back into the metal. However, we're seeing here we can, we can plate it with some other metal to protect it. So that's one way we can get around that problem. Okay, I want to look here at some examples. These are all going to be chemical changes, but I want to talk about them as a way of understanding, well, how do we know that that is a chemical change? So this is a reaction. We're actually going to be doing something similar to this in the lab later this semester. If you put copper into nitric acid, the copper will dissolve. You form a brown gas. The brown gas is actually not the copper. And then you get the liquid goes from colorless to blue in color. So that's a chemical change. You're not going to take all of that stuff and turn it back into copper metal. Very easily, you need a series of chemical reactions to do that. Here we're showing a match burning. Any kind of flame is evidence of a chemical change because you have energy being given off there. It's that energy is coming from something going on with a rearrangement of the atoms. And that's something we'll get into in more detail in a later module. But that's evidence of a chemical change. When we cook meat, if we cook meat, there is a chemical change going on. And you can recognize that because you see a color change that occurs. You see the meat changes in kind of its flexibility. It kind of becomes a little bit firmer in most cases, and that's evidence of a chemical change. You can't take the cooked meat, turn it back into raw meat. So that's a kind of a permanent change. Permanent changes are essentially chemical changes. And then likewise, a banana that's turning brown is also an example of a chemical change. Whoever made this PowerPoint says darker and less tasty. Personally, I prefer the brown bananas, but I know most people like them to be more green. The point, though, is that you can't go back, right? Once it's a brown banana, you don't get back to a green banana. These are all chemical changes. Whereas if you had something where you could go back, that would be an example of a physical change. Some properties of substances are important for us to keep track of in the lab for safety reasons, and we'll talk about this in detail in the lab related to the safety. But I just wanted to point that out, that these are all related to essentially chemical changes. So what chemical properties do those substances have that make them dangerous for us? So we'll talk about how to deal with that when we go through lab safety in person. And then here we're showing the periodic table. And I guess this is the first time we're seeing it. We'll talk about it in more detail in Module 2, so don't worry about understanding everything right now. But one thing we do on the periodic table is we often show some kind of a color coding that tells us, actually we're showing two color coding things here. We'll talk about this stuff, metals and nonmetals, in Module 2. But for now, we can see solid, liquid, gas. So the physical state of that substance at a given temperature, so this is probably at room temperature, is listed here. So you'll see most of them have used black letters, and those are the solids. And then we have a few that have the blue letters. So Br and Hg use the blue lettering. That's showing that they're a liquid at room temperature. And then some others have the red lettering, so mostly the ones over here. And then hydrogen, those are gases at room temperature. Okay, so these are showing the physical properties of these elements. And again, we'll talk about other details of the periodic table in a later module. So those were the things I wanted to emphasize related to understanding physical properties, physical changes, chemical properties, and chemical changes. I also wanted to briefly talk about intensive and extensive properties. This is not something that we have a picture for because it's kind of a concept more so than something you would look at. So for an extensive properties, they are dependent on how much you have. So something, as it gets larger, does that property go up? So the weight of something, the volume of something, those things go up. Those are what we call extensive properties. An intensive property doesn't change as you increase the amount of it. So temperature is a great example of an intensive property. It's the same temperature, doesn't matter how much you have. Other things like density, which is actually a ratio of mass to volume, are intensive properties, and we'll talk more about density later in this module. Mostly we'll talk about it during lab. And then other intensive properties are usually things that you're dividing by the amount, so dividing by either the volume or the mass to come up with. And we'll introduce some of those as we move on through the semester. So that is it for section 1.3. Feel free to move on to the next section.